Okay, so this is the last session for lesson 6. We're still talking about place value and trying to learn about the origins of it, where we get these numbers, and why numbers change when you go from one place value to the next. So let's jump right in with a warm up. Oh, so for this one, it wants to write each number in a decimal place value chart. We have these three number, or we have this main number here. That is 3 hundredths. The 3 is in the hundredths place. And it wants to know a number that's 10 times as great and 1/10 of that. So let's jump right into this chart right here. So I'm going to write in my main number here, which is 3 hundredths. So as we know, if we take this 3, and I'll use a different color here. If you want a number that's 10 times bigger, you just have to move it one spot over to the left, because here in this case, tenths are 10 times bigger. So a number that's 10 times bigger than 3 hundredths is 3 tenths. It also wants us to make one that's 1/10, which means it's going to be smaller, or we're going to divide by 10. So we're going to move this 3 in the hundredth spot over here to the thousandths spot right there. And that gives us a value of 3 thousandths. So again, every place value you move to the left is 10 times bigger. Every place value you move to the right is 1/10 smaller. So we're multiplying by 10 when we're going left, we're dividing by 10 when we go to the right. All right, so that was just a quick warm up for that. You all will turn to page 129. And we'll jump right in. It says shade the models to the right to show how the value of 4 hundredths is related to the value of 4 tenths. So I'm going to label these, and it doesn't matter which order, but I'll put the bigger number to the left because I always want to keep thinking numbers to the left in place value are bigger than numbers to the right of it. So I want to stay consistent. So let's put 4 tenths right up here. So since this whole grid here represents one whole number, we remember from the last couple days that one column is a tenth. So then we need 4 of those. So I'll shade those in. Over here, we have 4 hundredths, and we remember from that that one single cube or one single square is a hundredth. So we'll fill in 4 of those. And like we learned the other day, if you multiply by 10, that makes it bigger. If we divide by 10, that makes it smaller. So they want to actually have us do like a multiplication problem for this. So this will be, it shows division. So we've got to take 4 tenths, divide it by 10, and that will equal 4 hundredths. So that's actually what we're just showing right underneath our grids is a visual representation of that. All right, let's move on. Again, with the videos, if you're watching, you can pause if I'm going too fast for you. All right, Kieran showed that 8 hundredths, so this, we're going to write above that, this number right here is 8 hundredths. Showed 8 hundredths with the model below. And there's a problem with that. And it says, what's wrong with this model? Well, I'm looking at the model. I'm seeing from 0 to 1, and I'm noticing right away that this line is done up in tenths. So you can't, what's actually represented here is this number, 8 tenths. So that's actually inaccurate. If we're going to do 8 hundredths, that would actually have to be shown like right about there. So to answer this question, 8 tenths is shown. So they've got the wrong scale. And we'll talk later about scale in future lessons, but that's what was wrong with this number line. So if that looks familiar, it's also a lot like what we did yesterday in IXL. Let's move on to 3. Number 3. So anytime we're comparing two decimals, I would like you guys to make do-it-yourself place value chart. So draw one straight line up near the top and then do 1, 2, 3. These are the ones. Actually, hold on. Sorry. Strike that. Reverse it. So I'm looking at 486. This is hundreds. This is tens. This is ones. And make this a little mini column for just our decimal points. And over here are tenths. So let's compare the digit 8 in these two numbers. So our first one is going to be 486. Our second number is going to be 1.8. I'm going to circle these 8s right here. Now, we've talked so far about the fact that if they're one place from another, that's 10 times bigger. But what happens if it's two spaces away from each other? So what we have to do is do 10 times 10 equals 100 times bigger. So again, keep that in mind. If each space is 10, but we just keep multiplying the tens to do that. So the 8 in 486 is 100 times bigger than the 8 in 1.8. All right, go ahead and turn the page. This question is something else. So, but it's good. I like it. That's why we're still going to do it. It's comparing an ant, a bee, and a grasshopper. So these three bugs are being compared as far as their mass. So an ant has a mass of 5/1000ths of a gram. So let's put that in our chart. 0, 0, 5. The bee has a mass of 5/100ths. Put that right in there like that. And the grasshopper has a mass of 5/10ths of a gram. So you can already see the pattern with these fives. I'm going to go green for bugs. You can see that there are all these different sizes from one another. So putting them all in a place value chart is a very good way of comparing your different numbers or different values of these numbers. All right, part A is done. Let's go to part B. Shade the models to compare the mass of the bee and the mass of the grasshopper. So our bees right here, that is going to be 5/100ths. And we know that hundredths are represented on a chart like this by just a square. So there's 5/100ths. And then the grasshopper is 5/10ths. So that's going to be 1, 2, 3, 4, 5. And then write a sentence to describe the relationship between the two masses. Let's do it like this. Let's describe it this way. Since this value of the bee is actually, the bee is 1/10 the mass of the grasshopper. You could also say this a different way. And if I was in class, I'd be like, who can say this a different way? And someone would probably say the grasshopper is 10 times heavier, or it has a mass that's 10 times bigger than the bee. Part C, explain how many ants it would take to equal the mass of one grasshopper. Then write an equation using the measurements to show your answer. So it's like this. You'll notice that, let me use blue. So we're comparing this ant and this grasshopper. So that 5 is 2 spots over. And remember, if we're going up or going to larger place values, that's 10 times each. So 10 times 10 equals how many? 100 ants for every one grasshopper, because it's 100 times bigger. So the comparison there is you would need one for every one grasshopper, it's compared to one ant. So if you've seen the movie Bug's Life, that's kind of how it's kind of interesting that they have like the ants versus the grasshoppers in that. Or maybe it's a different bug than the ants, but I haven't watched it in a long time. Anyway, all right, let's move on. Let me clear this up. Got one more question. All right, so what is the number that has a value 10 times the value of 9 thousandths? This is simple. So, but let's do it this way. Let's see, I got my ones. All right, let's do this. These are going to be my ones. This is going to be my decimal point. And these are going to be my tenths, my hundredths, and my thousandths. And let's plug in the number. We've got 0.009. It wants to know what is a number that has a value 10 times the value of this. So we would need to move, we would need this 9 to be here, because we know that's 10 times. And this number is 9 tenths. So 9 tenths is 10 times bigger, 9 thousandths. Okay, so that's it for the notes. Today's assignment is going to be G12. It's compare decimals on a number line. So we can do that with just going to 70% and then 100% for your lesson.